Hi everybody. This video covers the first part of section 1 of chapter 4, and here we are going to talk about systems of linear equations. Yeah, I think I'm missing an S there. Shame on me. So I'm going to start off with a brief introduction with the intent of hoping to motivate why we're doing what we're doing. And then we're going to talk about the 3 approaches to solving linear equations: graphing, substitution, and addition/elimination. And then we'll talk about the 3 possible outcomes when you have a system of linear equations. And then on a follow-on video, we will talk about applications. And here is our motivating introduction, and this has to do with our famous break-even case, which we have discussed repeatedly throughout this course. So let's go. Suppose we manufacture and sell baseballs, and we sell baseballs for $4 a ball. And also, but we also have some costs. For example, our fixed cost, what we call our non-recurring cost to manufacture a baseball, is $200. And then our recurring cost is $2 per baseball. For every single baseball we make, we incur $2 of cost. And the question is, how many baseballs must we sell to break even, i.e. so that our revenue not necessarily exceeds but equals our cost? Because if it exceeds our cost, we're not breaking even, man. We're making money. Of course, we all want to do that. Okay, well, let's let X be the number of baseballs we sell. This is a math class, and as mathematicians, we like to use X all the time. And let's suppose and remember, we're selling baseballs for $4, so our revenue is going to be Y is equal to 4 times X. You sell 1 baseball, hey, you made $4. Sell 2, you made 8. Boom, boom, boom. Okay, now for our cost function is going to have a fixed cost, which will be the same no matter how many baseballs you make, $200. There it is. Our recurring cost is $2 per baseball, 2 times X. So this is the equation for our cost. This is the equation for our revenue. And it turns out that our break-even point is that value of X, which is a solution to both of these equations. So let's go ahead and plot them. Here's our revenue equation. Here it is. It's crossing the origin as you might expect, since there's no y-intercept. Well, the y-intercept obviously is 0, and it's going up with a slope of 4. Here's our cost equation. It has a y-intercept of 200 and has a slope of positive 2. These equations are what we call a system of linear equations. And the break-even point is that value of X, which is the solution to both of those equations, or specifically where those 2 equations intersect. And as you can see, it intersects at the point 100, 400. Okay, so we need 100 baseballs to break even, and if we break even, that means we're not making any money. Yay. But then again, we're not losing any money, so that's a cool thing too. Now notice here, if we were less than 100, say at 50, which is right here, that would be our cost, or that would be how much money we made, which is $200, but our cost would be $300. So we would be losing money. And if we go over 100, then as you can see, we will be making money, because this would be our cost, and our revenue would be somewhere up here. So this is a system of 2 linear equations, and that's what we are going to talk about today. Systems of 2 linear equations in 2 variables. So given the linear system ax plus by equals h, and the other equation cx plus dy equals k, where all of these are real value constants, they can be 0 or not, the ordered pair x0, y0 is said to be a solution to the system if it is a solution to both of the equations. And the set of all such ordered pairs is what we call a solution set. And if you are solving a system of equations, linear or otherwise, you are trying to find the solution set. Now, it turns out that if you have a system of linear equations and a solution does exist, then the solution set will have either 0 elements. If there is no solution, it will have exactly 1 element, or it will have an infinite number of elements. Those are the only 3 possibilities. Now, the three approaches to solving a linear system are graphing, substitution, and what we call addition/elimination. This is graphing. What do? You graph both equations on the same axis, just like what we have here. And if you do, there are three possibilities. This is possibility one. The lines intersect at a single point. The solution is basically that point. If that occurs, we say that the system is consistent and that the system is linearly independent. It may not be important now, but as you go on, you might find these things will be more relevant to you. The second possibility is this, where the lines are parallel. And if they're parallel, that means that they will never intersect. Therefore, there is no solution. The system is inconsistent. However, we do say that the system is linearly independent. So if the system is consistent, that means there is at least one solution. If we say that the system is inconsistent, there are no solutions. Now, one example I want to show you is the case where if you have two equations in slope-intercept form. For example, suppose you have the equation y is equal to 3x plus 1 and y is equal to 3x plus 2. Well, remember, this is the slope. These equations have the exact same slope. So if the slope is the same, you have two possibilities. They are either parallel or they're the exact same equation. Well, since they have different y-intercepts, they are not the exact same equation. They are parallel lines. So wherever you have an equation where you have the same slope but different y-intercepts, then they will never intersect. There is no solution, and the system is inconsistent, but the system is still linearly independent. And I want you guys to pay attention to this, because you will see a problem in your homework where the equations look like that, and that is how you handle it. So if you're paying attention, you'll see this. You'll be able to knock it out in 3 seconds. If you don't, it might take you just a little more work. Okay, and here is the third situation, where the line, where both equations graph the exact same line, and that is possible. And if that's the case, you will have an infinite number of solutions, and the solutions will be all of the ordered pairs on the line. We will say this system is consistent because, hey, we have at least one solution. However, this system is linearly dependent. And why do we say it's linearly dependent? Because you can express one equation in terms of the other one, which is kind of ironic, which is obvious since there would be the exact same equation. And let's go ahead and work on an example. And to do this, we are going to rearrange our screen just a little bit. Okay, so here we are. I have my calculator over here, and I have OneNote over here. And our example is to solve to 2 decimal places using graphical approximation techniques. In other words, using a graphing calculator. Okay, and you're going to have a couple of homework problems where you need to solve a system of equations using a graphing calculator. So to do this, and these are our 2 equations right here. Now to do this, we need to program the equations into using this button right here, which means they both need to be expressed in terms of y. Okay, so before we can do this, we have to solve both equations for y. So let's start off over here. We have 2x minus 5y is equal to negative 25. All right. Well, we can subtract 2x from both sides. These will add vertically. These will cancel. We will have negative 5y is equal to negative 2x minus 25. We can divide both sides by negative 5. And then we will have, these will cancel. We will have y is equal to 2/5 x minus 5. Negative 25 divided, no, plus 5, I apologize. Negative 25 divided by negative 5 is 5. Okay, there we go. So for the first one, I need to clear this. And I will have y is equal to 2 divided by 5 times x plus 5. There we go. Now for the next one, we're going to do the exact same thing. We start off with 4x plus 3y is equal to 5. Subtract 4 from both sides, 4x from both sides. Sorry about that line there. These will cancel. We will have 3y is equal to negative 4x plus 5. Divide both sides by 3. These will cancel. I will have y is equal to negative 4/3 x plus 5 divided by 3. Okay, let's go ahead and do that. Now to do the negative sign, I need to do this button right here. Negative 4 divided by 3 times x plus 5 divided by 3. And I can hit enter, don't really have to. And now I want to, well, let's make sure the windows are where I want them to be. So let's go over to window. I want this to be minus 10. Enter. I want x max to be 10. I want the scale to be 1. I want y min to be minus 10. I want y max to be 10. And I want the scale to be 1. And let's see what this looks like. Okay, that works. And right here is the solution. Now, how do we find the solution? Well, if you want, you can zoom in and take a look. But the best way to do this is to use the calculator to find the intersection for you. To do that, we're going to do second trace, which brings up the calc feature, and we want to find the intersection. So go down to intersect, hit enter. Okay, we want the first curve. Well, the first curve is a blue curve. The cursor's on the blue curve, so we just hit there. The cursor's on the red curve. That's the second curve. Now all we need to do is guess, and really we can pick any point we want since there's only one intersection, but let's just bring it over here and then hit enter. Okay, and this value right here is our intersection. The solution or the intersection occurs when x is equal to 1.923 and y is equal to 4.320. Now, while I go to the third decimal place, we are going to 2 decimal places. So we need to round. That means we need to know the third decimal place. So since the third decimal place is less than 5, we don't need to round up. Since this is less than 5, we don't need to round up either. Therefore, our solution is going to be the point 192, the x-coordinate, 1.92, sorry about that, comma, 4.32 for the y-coordinate. So this ordered pair would be the solution to that equation. Okay, now we are back in slideshow mode, and we are going to go into our second technique, which is the substitution method. And how does this work? Well, we're going to have 2 equations, and what we're going to do is we're going to use one equation to solve one variable in terms of another one. Say we're going to express y in terms of x. And then in the second equation, wherever we have a y, we're going to replace that with our expression in terms of x. Once we've done that, we can solve for x. Once we figured out what x is, we can use the very first equation to figure out what y is. Now, what the heck does all that mean? Well, let me show you in an example. So in your homework, you might be given a system of equations kind of like this, where actually one has a y by itself and whatnot. An equation like this is right for substitution because as soon as you figure out what this one is, which is relatively easy to do, you're off to the races. So what we're going to do is we're going to use one equation to express one variable in terms of another variable. And specifically, we are going to use this equation. So let's go ahead and do that. Suppose I have 2x minus y is equal to negative 6. Well, I can add y to both sides. And I can add 6 to both sides. And if I add vertically, well, these cancel. These cancel. All I have over here is 2x plus 6. And over here, I have y, which is pretty much what I have here, just flipped around. You can do that. Okay, let me write that down again. Y is equal to 2x plus 6. So I use this equation to express y in terms of x. So in the first equation, wherever I see a y, I'm going to replace it with this. That's what I did here. And that's also what I did here. And then we just go ahead and we simplify. 2x, 2 times 2x, using distributive property. 2 times 2x, 4x. 2 times 6, 12. Now I have like terms, 3x plus 4x. They can combine to 7x. 7, and then I have 7x plus 12 is equal to negative 2. I can subtract 12 from both sides. Then I will have 7x is equal to negative 14. Divide both sides by 7. And then I have x is equal to negative 2. Once I figured out what x is, I can take this and put it back into this equation right here. And if I do, that's pretty much what I did down here. I have y is equal to 2x plus 6, making the substitution. 2 times negative 2 plus 6, well, that's just negative 4. Negative 4 plus 6 is equal to 2. So I have negative 2 for x, positive 2 for y, and this would be my solution set. So relatively straightforward for certain classes of problems. For other classes of problems, substitution can be a difficult endeavor. But for this class of problems, for problems like these, where you have a y with a coefficient of 1 or negative 1, it is a pretty straightforward endeavor. The last approach is what we call elimination by addition. And here what we're doing is we're going to transform linear equations so that we arrive at equivalent equations where the solution happens to be obvious. Now, what do I mean when I say an equivalent equation? That is an equation which has the exact same solution set. And it turns out that this approach serves as the basis for any computationally based technique for solving systems of linear equations, or basically systems of equations in general, linear or otherwise. Okay, now these are the types of operations that will produce for you equivalent equations. For example, you can flip the order of equations. That's actually pretty obvious. That's what we mean here. If you take any equation and multiply it by a non-zero constant, then the solution set has not changed. So you have an equivalent equation. And also, if you take two equations and add them together, the sum of those two equations is an equivalent equation, i.e. it has the exact same solution set as the original system. Furthermore, you can actually take an equation, multiply it by a constant, and then add it to another equation, or another equation multiplied by a constant. The solution set has not changed. And I know at least in high school math, and even middle school math, you probably have used this on a couple of occasions. So how does all this stuff work? Well, I'm glad you asked, because I'm going to show you. Here we need to solve this system of linear equations by addition. Now what we want to do is we want to come up with equivalent equations that when we add them together will remove one of the variables. And notice here that I have negative 2y and I have positive 3y. If I multiplied this equation by 3, and if I multiply this equation by 2, I will have a coefficient of negative 6 here and a coefficient of positive 6 here. Negative 6 here and positive 6 here. And if I add them together, these equations will go away and I will have an equivalent equation which is a function of x only. Okay, so that's what I'm going to do. I'm going to multiply this entire equation by 3, and if I do, I will have 15x, 3 times 5, minus 6y is equal to 36. My next equation is going to be 4x plus 6y is equal to 2. Now, according to my instructions here, I can add those two equations together, which is why I wrote them the way I did. So I'm going to add them up. And remember, when we add, we can only combine like terms. These are like terms. They add to 19x. These cancel. And then here we have 36 plus 32, which is 38. Isn't that convenient? And now I can solve for x. What I can do is I can divide both sides by 19. And I have that x is equal to 2. These cancel, and 38 divided by 19 is 2. So now that I have x, I can use any equation that I can use either this equation, or either of these two equations to figure out what y is. It doesn't particularly matter. I'm going to go ahead and use the second equation. There it is. Okay, so there I'm going to have 2. And instead of x, I'm going to put in my value for x now. 2 times 2 plus 3y is equal to 1. All right, well, that's 4. So I'm going to have 4 plus 3y is equal to 1. All right, I'm going to subtract 3 from both sides. I'm going to subtract 4 from both sides. These will cancel. I will have 3y is equal to negative 3. 1 minus 4 is negative 3. Divide both sides by 3. And I have that y is equal to negative 1. So my solution set is going to be the point 2, comma, negative 1. Does that work? Well, let's go ahead and find out with using the first equation. 5 times 2 minus 2 times negative 1. Well, that's just going to be 10 plus 2, which is equal to 12. So it does indeed work out. Okay, well, let's suppose that you have an inconsistent system. And if I say that you have an inconsistent system, what does that mean? That means there is no solution. So we're going to use the elimination approach, and we're going to see what happens when we have an inconsistent system. Okay, so notice here that I have 6x plus minus 3y is equal to 12, and here I have negative 18x plus 9y is equal to 1. So it seems reasonable that I should multiply this by 3, because if I do, I will have an 18x, negative 18x, they will cancel. So let's do that. And if I do, I will have 18x minus 9y is equal to 36. And over here, I'm not going to do anything. I have negative 18x plus 9y is equal to 1. And now I'm going to add them together. If I do, these cancel, I have 0 is equal to 37. So what can you tell me about this statement? Well, hopefully you'll say, well, that is a bunch of malarkey. That is, or what we will say mathematically, this is a false statement. So if you use this approach and you come up with something that is false, that will tell you that there is no possible solution, or that the solution set is the empty set, or that the system is inconsistent. Now in this example, we are going to solve a system with an infinite number of solutions. And if there's an infinite number of solutions, that means that both of these equations plot the exact same line. So the question is, what does that look like when we are using elimination? Well, notice here that I have a 6x and a negative 18x. Now, if I multiply this equation by 3, my coefficient will be 18, and when I add the two equations together, they will cancel. So let's go ahead and do that. I'm going to multiply this equation by 3, and if I do, I will have 18x minus 18y is equal to negative 6. And then over here, I have 18x for the next equation plus 18y is equal to 6. Okay, adding them together, these cancel, I have 0. These cancel, and I have that 0 equals to 0, which is a true statement regardless of the value of x and y. Okay, so if that's the case, we have an infinite number of solutions. If the statement is true, you have an infinite number of solutions. Now for the other examples or possibilities, if the statement is false, like 0 is equal to 5, then it's inconsistent. If you have something like x is equal to, say, a number, let's just say 3, then you know that the solution will be exactly 1 point. And this is the last example for our video, and the primary reason why I'm showing you this is because you actually have a couple of homework problems that look like this particular one. So notice here we have 6x, we have a system of two equations. This one, and you don't need to use elimination by addition if you don't want to. It's kind of, there's really no point why you should. Here we have 6x plus 0 times y is equal to 24. So what is 0 times y? 0 times y is 0. So this reduces to 6x is equal to 24. Okay, how do you figure out what x is? Well, just divide both sides by 6. And we have that x is equal to 4. Now look at this one right here. What's 0 times x? 0 times x is 0. All right, so here we're going to have minus 4y is equal to 16. Divide both sides by minus 4. And then you have y is equal to negative 4. And therefore your solution set is going to be 4, negative 4. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. Stay tuned to the next video, which will go over the homework problems in 4.1b. And with that, this is Bob Boyle, signing off.